All right, this is the Math 136 final exam review for day one, also using version A of the review. We're going to start out, this first video is going to be the first 9 examples, and then there will be a part 2 with the second 9 examples. So looking at the first example, it says simplify the expression, and we have this rational, it's complex rational expression because it's fractions over fractions. And since this one is a single fraction over a single fraction, the easiest way or method to deal with this is to use multiplying by the reciprocal. If there were multiple fractions on top and bottom, we might want to check the LCD method, or you could still use multiplying by the reciprocal, but you would have to combine the fractions first before doing that. So to multiply by the reciprocal, you write your numerator of the first part. So that's 3 over x minus 4. So that's the numerator fraction. Divided by would turn into multiply, so this is going to be times, and then it's the reciprocal of the denominator portion. So x squared minus 16 over 4x. Then we would try to simplify this by reducing or factoring anything that we see. So I would factor that difference of 2 perfect squares in the numerator of the second fraction. So I have 3 over x minus 4 times, on the numerator, x minus 4 times x plus 4 would be the factoring of that, all over 4x. Now, because there is multiplication here, we can cross reduce since everything is multiplying. And then that would give us just 3 times x plus 4 over 4x. Now that's one way to write the answer. You could obviously distribute that and make the numerator 3x plus 12, but there's no common factor that we can pull out of both top and bottom to reduce any further. When looking at number 2, notice there is an equation symbol now. So this is a solving problem. It even says that in our directions, we're solving for x. When you're solving a rational equation, you want to make sure that you know what your restricted values are. So the first step is usually to factor all of your denominators completely and look for any restricted values. So it looks like we cannot plug in a -3 or a +3 because that would make different denominators turn into 0 or make it undefined. Now, when we go to solve this, we're going to use the method of clearing out everything by multiplying by the LCD. And the reason we can do that without worrying too much is we've made our restricted list. So as long as we know that neither one of these can be answers, we can use that technique. So if the LCD for this problem is going to be x plus 3 and x minus 3, because that's our common denominator that we would need to make all of these match. But instead of getting a common denominator, if we multiply both sides of our equation, and this has to be an equation for this to work, by the LCD, then we can clear out those denominators. So I've got x plus 3 times x minus 3 times the first fraction or term, which is the 4x minus 5 over x plus 3, x minus 3, equals x plus 3, x minus 3 times the second fraction, which is 2 over x plus 3, minus x plus 3 times x minus 3, there's my LCD again, times 7 over x minus 3. This allows us to cancel out as we work from left to right. So the first one will just be 4x minus 5 because both parts of the denominator were there. And then it is 4x minus 5 equals, on the second term, we have an x plus 3 in common on top and bottom. So that's going to cancel out and leave me with a 2 times an x minus 3, which I will distribute on the next line. Minus, I have my x minus 3 is going to cancel in the last term, and that would leave me with a 7 and an x plus 3 times each other. So we're going to do our distributive property next. So 4x minus 5 equals 2x minus 6 minus 7x minus 21. Combine like terms on the right side. So 4x minus 5 equals negative 5x minus 27. I'm going to get the x's on the same side together, so I'll add 5x over. So that's going to make the left side 9x minus 5 equals negative 27. Add 5 to the right side, or actually to both sides. So that's going to be 9x equals negative 22. And we divide by 9 to get x by itself. Now, as long as we haven't made any arithmetic errors and we've checked it against our restricted values at the top, if this answer does not match those and we've done everything correctly, then the answer should be good. So the answer is x equals negative 22 over 9. If you wanted to be very sure, you can obviously show the check. Use your calculator, work that out. So 3, it's a word problem. This is a uniform work rate problem. And with those, it means that the person or the object or the thing, whatever it is that's doing the work, is working at a pace where their speed does not change and they never take any breaks. So it's uniform work rate. So it takes a girl 55 minutes to deliver the papers on her route. If her brother helps, it takes only 20 minutes. How long would it take her brother to deliver the papers by himself? If necessary, round to 1 decimal place. So the way I like to think about this is I want to get to know, because they're definitely working at different speeds, because they were faster when they were together. The girl was obviously slower by herself, but we want to measure that as how much of the job did they get done in a single moment of time. So for us, that would be in a minute. So if it takes her 55 minutes to do the whole route, and she's working at a consistent pace the whole entire time with no breaks, that means that the girl did 1/55 of her route or the job per unit of time. So that's per minute. And then the boy, we don't know by himself, but we do know the girl and the boy together. It took them 20 minutes when he helped. So that would be 1/20 of the route per minute. So the boy, since we don't know his time, we just know that he works uniformly like his sister. It's going to be 1/x because we don't know how much time it took him to do it by himself. That's what we're trying to solve for. So x is going to stand for the time for the brother to finish the route. That's what we're searching for. Okay, so the girl, which is 1/55, her work rate plus the brother's work rate should equal their work rate together. So if we want to solve this, there's a couple of different ways. You could try to get a common denominator and add and get one fraction and then cross multiply, since you'd have a single fraction on each side of the equal sign. A quicker method might be the LCD method. 55 and 20 both go into 220. You could check that by making a list of all the multiples of those numbers. And we also need an x. So 220x is what I'm going to multiply everything by to clear out those fractions. So 220x times 1/55 plus 220x times 1/x equals 220x times 1/20. Okay, so if we multiply this by everything, that's going to give me 55 goes into 220. You can use your calculator. This goes in 4 times, so that's going to be 4x. The x cancels in the second term, so that's just going to be plus 220. And then in the last side equals the 220x over 1 times 1/20. That 220 goes into that 11 times, so that's going to be 11x. I would subtract the 4x to the other side, and that's going to give me 220 equals 7x. And then we're going to divide by 7. Now the directions did say to round to 1 decimal place, so I'm going to actually do the division here. And 220 divided by 7 is 31.428. The 2 is in the second decimal spot, so I'm going to write that out first. It's 31.428 dot, 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 dot. We're rounding to the first decimal place. So we look right behind it, it's 2, so that does not change this. So it's going to be 31.4, and we need our unit. The brother is working in minutes just like the sister. So he is quicker than his sister. So it took him only 31.4 minutes to do the route by himself. Okay, for number 4, we're solving a inequality and then expressing our answer in interval notation. This is a compound inequality. It's a string, and you can split it into 2 separate problems if you want, but you can also solve it as one piece, as long as you know that if you multiply or divide by a negative number, you have to flip the direction of the inequalities. So I'm going to copy it down. It's -4 less than 3x plus 1 all over 8 less than or equal to -2. I want to get x in the middle by itself, so I'm going to multiply all 3 parts, because essentially it's like 3 sides, by 8. That's going to be -32 less than 3x plus 1, since the 8 would cancel in the middle, less than or equal to -16. To get x by itself, next I would subtract 1 from all 3 parts. So that's going to be -33 less than 3x less than or equal to -17. And then we're going to divide everything by 3. So it looks like I'm getting negative 11 less than x less than or equal to negative 17 over 3. And we do not want to turn that into a decimal. They did not ask us to. You only turn things into decimals if you have directions to do so. So this is what we call the inequality answer. We want the interval notation. Interval notation tells us the starting and ending of the shading of the inequality, essentially all the solution set. So this starts at negative 11, comma, and then it ends at negative 17 over 3 if we were to shade this or color it in on a number line. And then to know if you have parentheses or brackets on either side, if you do not have an equal to, it's a parentheses. If you do have an equal to, the number is included, so it is a bracket. So it'd be parentheses negative 11, comma, negative 17 over 3 bracket. So that says we would shade everything in between there, including this endpoint, but not the negative 11. Okay, so for number 5, we have solve the following inequality and express your answer in interval notation. This is an absolute value inequality. And to solve these, you always need to isolate the absolute value portion first. So I have the absolute value of x minus 7 plus 3 greater than or equal to 6. That plus 3 is not in the absolute value, so we're going to move it to the other side by subtracting it. So I have absolute value of x minus 7 greater than or equal to positive 3, because it's 6 minus 3. And then this is where you have to know the two different types of absolute value inequalities. If you have a less than, you're looking for distances that are very close to your center of your kind of shaded area. If you have a greater than, you're looking for things that have a distance further away. So when you have a less than, you're going to get a string sort of like what we had up above, where you have something less than something less than something. You have that little string inequality. When you have a greater than, you have to have shading in two opposite directions. So for us, we have a greater than or equal to. So the way we set this up is to shade to the left of our center, we say x minus 7. And then this changes to a less than because we want to shade to the left, so less than or equal to, and we want to be on the left side directionally. So when we talk about direction, left would be to, like on a number line, would be to the negative side, so negative 3. Or, because this is an or problem, because the other opportunity is that we could go 3 away from our center on the right and then shade to the right. And in this case, it's just really writing the inequality you had up above without the absolute value. So x minus 7 greater than or equal to, so shading to the right of the positive direction, which is 3. So we should get shading in two opposite directions, and our center of our graph is 7 here. Sometimes that's a little more complicated depending on if there's a number in front of x, but for us, this is really going to be, if 7 is our center, because that's what would make that equal 0, we're going 3 in either direction and shading away from the 7. So we should see that that makes sense when we solve this in just a second. So I'm going to add 7 to this, both sides on this one. So that would be x is less than or equal to positive 4. And then add 7 on both sides here. This is x is greater than or equal to 10. So if you think about x minus 7 having a center point at 7 on the number line, and you go 3 on either direction, that would be 4 and 10, and then we're shading further away from our center. So that has that absolute value or distance being greater than or equal to 3. And then we want to write this in interval notation. So anytime you have an or, you have a union symbol, and then this would be negative infinity up to 4 and including 4. So that'd be a bracket. And then on the other side, we start shading from 10 to positive infinity. So there is our solution set for number 5. Okay, for number 6, it says solve the following inequality and express your answer in interval notation. Now this is a polynomial inequality. Anytime you have a polynomial inequality where your power is x squared or higher, and you have maybe a rational inequality, which means you have x's in a denominator of an inequality problem, both of those situations are much more complicated than just solving a simple inequality. There's multiple things that can go on with the signs and how they become either negative or positive. So we have to use what we call a sign chart method or a test interval method to prove where the shading should be. So the first step in a polynomial inequality is to try and factor, well, you want 0 on the right side, which we already have, but then you try to factor the left side. So I have 3x cubed minus 2x 2x squared minus 27x plus 18. I'm going to pull a common x squared out of the first two terms because I'm going to try factor by grouping. That would be 3x minus 2 left in a parentheses. And then negative 27x and 18 have a negative 9 in common that I can pull out. That would also then divide out and leave me with 3x minus 2. And then I have my less than 0 sign. I want to bring that down. I have a common binomial that I can pull to the front of 3x minus 2. And then the leftover part would be x squared minus 9, less than 0. X squared minus 9 factors again into x plus 3 and x minus 3. So what I have right now is 3x minus 2 times x plus 3 times x minus 3 is less than 0. Where a lot of students will go wrong on this problem is they think they can solve this like an equation and set each part less than 0 and go from there. That's not true because this is an inequality. Inequalities do not follow the same exact rules always as equations. They are different. So what we do is we do find what makes each of these equal 0, but then we use a sign chart to test each side of those values to see if the overall value for the problem comes out positive or negative. In this case, we want it to be negative because we want less than 0. So this would be, if I solved this, this would be 2/3, add 2 and then divide by 3. The second parentheses would be a negative 3, and the third parentheses would be a 3. So we usually make a number line when we're doing these test sign charts. And we're going to place these three critical values, kind of that's what we like to think of them as, on our number line. And we do it from least to greatest. So negative 3 is the smallest, and then 2/3, and then 3. It's crucial that you get them in numerical order because you're going to have your interval notation built around this. So I'm going to use a different color to emphasize my interval notation. So this first interval is everything from negative infinity to negative 3, and we need to know if it's going to have a bracket or not, and that's dependent on this symbol right here. This is going to be an open circle or a parentheses because there's no equal to in our inequality. And then we would have parentheses, everything from between negative 3 and 2/3. And then the third interval is going to be 2/3 to positive 3, both in parentheses, and then parentheses 3 to positive infinity. Now, I always draw a line here to separate because I'm going to write myself some notes. I want a test value from each interval, so I know what I'm testing. I need to look at how it affects my left side of my problem. Does it make these three factors come out positive or negative? One way to do that is to test it in each factor, and then we multiply them together to see the overall sign. And the goal is whatever we get at the end, we want it to be less than 0. So we want it to be negative. So a number that is less than negative 3 would be negative 4. You could use a different number, but that's just the first one that popped into my head. Anytime I change from negative to positive numbers, 0 is in the interval, so that's an easy one to test. Between 2/3 and 3, we could test positive 2, and bigger than 3, maybe we'll do positive 4. Now, you can actually write down what the number is and work it out, but you don't really need that. You just need to know the overall sign of this multiplication when we're done. So, because we're just trying to compare it to 0. 0, remember, has no sign. So we either want to be positive or negative to know if it's true or false. So if we plug in negative 4, that would be negative 12 minus 2. So that's going to be a negative sign overall. Negative 4 plus 3 is also negative. Negative 4 minus 3 is also a negative number. You multiply the three factors signs together, 3 negatives still multiplies to a negative. If I plug in 0, I get negative. If I plug in 0 to the second factor, I'd get 0 plus 3, so that's a positive. 0 minus 3 is a negative. Two negatives all overall multiplied together makes a positive. Because remember, the positive can't change signs. Only a negative multiplying by something else can change its sign. And then we plug in 2, so that'd be 6 minus 2, so that's a positive. 2 plus 3 is a positive. 2 minus 3 is a negative. One negative overall multiplies to a negative. And then we get, if you plug in 4, you get all three of them come out positive, which means that region is overall going to multiply to a positive. So we don't even need to know what the exact number is. We just want to know if the y coordinate, essentially, if we were graphing this, would come out positive or negative. So since we want negative, I'm going to circle just the columns that ended with an overall sign of negative, so that's less than 0. You go up here and you grab your interval notation, and that becomes your answer. And of course, we separate it with a union, again, because it's either the first interval or the second interval could work. So negative infinity to negative 3, both with parentheses, union with parentheses 2/3, comma 3, close parentheses. Okay, so let's look at number 7. So we're determining the domain of the function, and we have f of x equals the square root of 2x plus 30 all over x squared plus 3x minus 28. And we want to express our answer in interval notation. So there's two things going on with this problem. First of all, if you have square roots, you have to worry about the inside not becoming a negative because that would make it an imaginary number. And that domain of functions is always in the real numbers only. So we do have to make sure that we keep any even roots. The inside of those need to stay greater than or equal to 0. So that's one condition we have to worry about. We also have x's in our denominator, so it's possible that maybe something could make us divide by 0, and that would make it undefined. So the best way that I know to approach this type of problem is to start with the radical, since there's two real issues going on. And notice that because this is a square root, to keep it to be a real number, we have to make sure 2x plus 30 stays greater than or equal to 0. We want to know what's the threshold for that. What's the smallest x can get? So if we subtract 30 over, that would be 2x, oops, sorry. My computer just jumped. 2x is greater than or equal to negative 30. And then we divide both sides by 2, so x is greater than or equal to negative 15. So I already know for my answer, just because of that singular condition, I can never get anything less than negative 15. So I'm going to go ahead and start a little bracket over here that says negative 15, comma, because I know I have to stay to the right side of that. So that condition is going to be met for the top as long as we keep our x's above or equal to negative 15. If you put in negative 16, you'd be in trouble. You'd have a negative under your square root. For the denominator, you need to factor the denominator because it's a trinomial. So that's factors of 28 that are different signs because it multiplies to a negative, but they then become positive 3 when you add them together. So that would be a positive 7 and a negative 4 for the factoring. So x plus 7 times x minus 4. And then when we solve those, we get that x cannot equal negative 7 or positive 4 because you set them equal to 0 and solve both cases. So those are two of our restricted values. Trying to write small is not working. So x minus 4 equals 0. I'm just writing kind of how we knew that those were the two restricted values. Now, where you get into an issue here is you need to figure out if these two numbers right here have already been excluded by condition 1. So negative 15 on a number line, we're not really shading or anything, we're just looking at it, is right over here somewhere. Negative 7 would be greater than that, and so would 4. So since we're shading to the right because of our negative 15 being greater than or equal to 0, or sorry, our x is greater than or equal to negative 15, we have to make sure we don't use these two restricted values. So the way we do that is we put open circles or we skip those numbers. So that breaks our interval up from one interval into 3 separate intervals. So this is going to be from bracket negative 15 up to negative 7 with a parentheses, union, and then negative 7 to 4, because we are skipping the exact numbers of negative 7 and 4, and then union from 4 to positive infinity. So there is my domain. Those are all values that are allowed to be plugged into this function because the answer we get is still a real number. All right, we have 2 remaining questions for part 1. And then, like I said, there'll be a part 2 video for the other 9 questions for day 1. So it says, find the equation for the function that is finally graphed after the following transformations are applied to the graph of y equals x squared in the order listed. So we're going to shift our graph to the right 2 units, reflect it about the x-axis, and then shift it down 4 units. So I like to do these in stages. So we have y equals x squared. So stage 1 says shift the graph to the right 2 units. When you have a shift to the right or left, that happens inside the function's parent graph. So for our function, it's x squared. So it's happening inside the x squared. So, and then you have to remember that anytime you shift right or left, it's opposite of what your sign is here. So you're going to be doing a -2. Now, the way I check that to make sure it's right, if you plug this number back in, you should get 0. So 2 minus 2 is 0. So a shift to the right is actually minus the number, okay? Whereas a shift to the left would be plus the number. So that's our first stage. Now, to do a reflection around the x-axis, that's actually changing the sign of all your y values. Anything that affects y happens on the outside of our parent function of the squared part. And reflections just mean we put in times a negative in front of this. So there's a -1 here, but we don't have to write the 1. So this negative in front of the parent function, if we work that out, that changes all of the signs of our y values. So that's going to make that flip upside down over the x-axis. And then finally, we're going to shift down 4. So that means we're making all of our y values smaller by 4. So we have a -4 at the end. So remember, when you're doing transformations, anything that happens to x happens kind of inside the parent, and it's opposite or operation to kind of what you're thinking. Anything that happens to y values, it's going to be outside of the function, the parent function, and it's going to be exactly what you think. So a minus for down. So that is the final answer. This is our transformation with all of the transformations that they listed in order. Okay, so let's look at number 9. Same idea, but our parent function this time is the square root of x. So reflecting across the y-axis actually means this. So say your graph looked like this, it's going to flip over here. That doesn't change the y values at all. It changes your x values. So anything that changes x values, it happens inside the parent function. So we multiply by a negative in front of the x inside. Stretching vertically by a factor of 2, that means you're going to be increasing your y values by double of their size. So that's going to be in front of the square root of x, square root of negative x, I should say. So whatever we do here, then we've got our y value, our current y value, we're doubling it. We're stretching it vertically or doubling its height. And then shifting up 5, just like before, that would happen at the end. And it would be a +5, exactly what you think. So there is my equation for that one. And that is the end of the part 1 video for day 1 review, and there will be a part 2 video coming very soon.